Hi everyone, welcome to section 3.9, derivatives of exponential and logarithmic functions. In this section, we'll learn how to take derivatives of exponential and log functions and see how they model things like growth and decay. Let's start with exponential function. An exponential function has the form f of x equals a to the x, where a is greater than 0 and a is not equal to 1. Some examples are 2 to the x, 3 to the x, and e to the x. The key idea is that the variable x is in the exponent. Now let's look at a special case. F of x equals e to the x. This is called the natural exponential function. What makes it special is its derivative. The derivative of e to the x equals e to the x. So the function stays the same after differentiation. In general, if we have e to the g of x, then the derivative is e to the g of x times g prime of x. Here we have a composite function. The outside is e to something, and the inside is g of x. So we use the chain rule. So we take the derivative of the outside and multiply by the derivative of the inside. So remember, exponential function looks like a to the x. The natural exponential function is e to the x, and its derivative is itself. Let's work through some examples. We want to find the derivative of f of x equals e to the 3x. Let's break this down step by step. The outer function is e to the 3x. The inner function is 3x. To find f prime, we use the chain rule. We keep the original function and multiply by the derivative of the inner function. The derivative of 3x is 3, so we have 3 times e to the 3x. So the final answer is f prime of x equals 3 times e to the 3x. Now, let's look at an application. We're given 8 of t equals 1000 times e to the 0.3t. This represents the mosquito population after t days. We are asked to find the rate of change of 8 of t after 4 days. So what we really need is a prime of t, and then evaluate it at t equals 4. Step 1, we need to differentiate 8 of t. Eight of t is 1000 times e to the 0.3t. First, we keep the constant, and then we differentiate e to the 0.3t. Using the chain rule, we keep e to the 0.3t the same, and then multiply by the derivative of 0.3t. The derivative of 0.3t is 0.3. And 1000 times 0.3 is 300. So a prime of t equals 300 times e to the 0.3t. Now plug in t equals 4. A prime of 4 equals 300 times e to the 0.3 times 4. And 0.3 times 4 is 1.2. A prime of 4 equals 300 times e to the 1.2. If the question asks for an exact answer, then we leave it as 300 times e to the 1.2. If the question asks for an approximation, then we convert this to a decimal and follow the rounding instructions. For example, this is approximately 996.035. And this is the rate of change of mosquito population after 4 days.